This video is brought to you by Sportland, quality, integrity, and tradition. All right, today we've got a prep table multiplex. So it has two separate reach-ins controlled by one condensing unit. It's this one right here. So it's not working, this top one. So we need to dive into that and see what's going on. You gotta be smarter than the average bear. I will admit, for many years, because I've done this restaurant for many years, I fought this shroud when it's just two screws that hold it on. So, duh. All right, we got this open, so looks like we've got a service cap right here. It has refrigerant in it. Always smell it. Doesn't smell burnt. We're going to dive into this guy. It's not running, so we need to look into it. We'll get some service gauges on it. All right, my electrical control panel's right here. So we're gonna start at the fuses. It's these ones right here. I just know this one. So this is the incoming, 208 volts, and then outgoing, 208 volts. So we've got power going to the condensing unit. Why the condensing unit's not turning on, we don't know. Before we put gauges on there, we are going to put them on no matter what, but we're going to check the pressure control, see if we're open, and then dig into the time clock in the electrical box. Okay, we have a dual pressure control. So what's going to happen here is this is going to control the compressor. So you have a high pressure side and a low pressure side. If the system pressure gets low enough, it shuts the compressor off, but then it'll also turn it back on when it gets high enough. And then if the high side pressure gets too high, it shuts the compressor off. This is to protect the compressor from catastrophic failure. If you lose a condenser fan motor, the system pressures are going to go up really high, and that could damage the compressor if it got high enough. So the high pressure control protects it. In our situation, we have a multiplex system. We have two sets of reach-ins that are controlled by one compressor. So each one's going to have a thermostat and a solenoid valve, and each reach-in can independently turn on and off. If both of them were to turn off, then the system pressures would stop at the liquid line service valve down at the coil, and the low pressure would get lower and lower and lower until the pressure control turns it off. So in this situation, we are looking for what kind of voltage we have across these terminals. Now, this is just a switch, this particular control. We have 0 volts. Now the question is, do we have no voltage at all, or do we have a closed switch? So I'm checking to ground right now, and I have no voltage to either terminal to ground. So that means that this pressure control does not have any voltage at all. So we need to figure out where the disconnect is at. All right, what I didn't tell you is that I had a service technician here yesterday, and my service technician diagnosed a bad compressor. Okay, I'm here to get some information so that I can quote an appropriate replacement compressor, but at the same time, we're evaluating the system, evaluating the diagnoses, okay? So, we had no voltage at the pressure control. I come over here, and this is our power right here coming into the thing, and it's completely disconnected. So my technician disconnected the power because he diagnosed a bad compressor, okay? So we're gonna go ahead and wire that back in, and we're going to evaluate the diagnoses and or size the equipment up for replacement if need be. Boy, the wiring for this system is a giant mess. Completely not correct. There's all kinds of weird stuff. So if I did it right, it's not going to blow up, but there's a good chance it's going to blow up because I really didn't spend a lot of time on this. So this is really a 1, 2, 3 please don't blow up moment. So I put the defrost clock into defrost, so the odds of it blowing are slimmer than usual. So we're going to go ahead and energize power here. I can remember how to actuate this guy. Okay. Defrost clock has a red light, which is good. And we're going to go ahead and flip this guy on. The compressor sounds like junk. So we're going to turn it off real quick. Okay. And we're going to go ahead and put service gauges on it. So it started, but it's just sounding really rough. All right, here we go. We're going to start this guy back up again. We're drawing 18 amps of current. We have minimal pumping going on, but there's something there. There's clearly something wrong with the valves, and it looks like we shut off on overload. So we were not drawing locked rotor amps. We were definitely running high current though, but you saw that it was pumping, but it wasn't pumping correctly. Yeah, so we definitely got something going on inside the compressor. Everything's wired correctly as far as the starting components and stuff go. And we know that the thermal overload's working because it clearly clicked it out. And yeah, there we go. See, it's trying again. 17 amps. I was trying to get voltage reading, but it's not going to do it. But we know we have 208 volts. But yeah, this guy has got something internally bad. It's locking up. Something's going on in there. Condenser fan motor's running. Everything's doing everything it can. You can see it tries to pump, but it just sounds really rough. So yeah, we've got a bad compressor on this guy. Locked rotor amps is 31 amps. We're not drawing locked rotor, so it's not completely locked up, but something's internally bad inside that compressor. All right, I have it turned off for now. What we're gonna do is we're gonna give them a quote. Now, this is an R22 system. We're gonna think big picture here, and I'm gonna talk to the customer and see how they want to approach this. At a minimum, if they want to, we can put up a condensing unit with POE oil in it, and we can probably just go ahead and convert it to 448A and leave the existing evaporator coils. Or we can go the route of replacing everything. But it's important with the 448A because it uses our 22 TXVs. We may have to make a little bit of an adjustment, but that's it. We can utilize the existing evaporator coils and go from there. But if the customer wants to accept the big picture quote, we will replace the condensing unit, both evaporator coils. We will not replace the line set because this particular restaurant, it's going to be a disaster to change the line set. It's enclosed behind stainless steel walls and stuff, so we're going to have to utilize it, but I have to make sure that our existing line set sizes would be appropriate. We're running, it looks like a 1/2 inch, 1/4 inch for the line set. This to me looks to either be a 1/2 or a 3/4 horsepower condensing unit. Downstairs, my initial, I'm going to write everything down, but we have 1000 BTU evaporator coil, and then the other one's about an 800 BTU evaporator coil. So we're running about 1800 BTUs. Realistically, we'll look at the numbers and what the performance at 448A is. We'll probably get away with a 1/2 horsepower condensing unit off the top of my head, but once I look at the BTUs, we'll see. We may have to go 3/4, it just depends. But when you go bigger, you want to be cautious because if you go too big, you can affect the evaporator TDs, and you could affect the compressor cooling, because if the suction line's not big enough and we're not bringing enough gas back, we could overheat the compressor and cause premature failure, essentially. So we're going to do some calculations and figure out what exactly we need to do, and then see where the customer wants to go with this one. I don't believe in leaving job sites a mess, so I put everything back together, even though it doesn't work. We put it all back together. I'm going to put the shroud back on. But I'm looking at this one right here because I installed this a couple years ago. This is similarly sized, I believe, so I'm going to take some numbers off of this equipment. More than likely we're going to end up doing something like this, where, see, this existing condensing unit, that receiver is not big enough. It's not meant for a remote application. That condensing unit is an indoor condensing unit, and it works fine under a shroud like it is, but the receiver is not sized appropriately. So I bet you that this system probably takes 4 or 5 pounds of gas, and there's no way that we can pump down that receiver at the king valve and store all the refrigerant in that condensing unit. This often happens on older systems like this. So when and if we size a new unit, I'm guessing this is probably a 1/2 or a 3/4 horsepower condensing unit, but look, I added a bigger receiver because I didn't necessarily need to go too big. So we'll find out. I'll get some numbers off this guy, and we'll kind of use those in our process of evaluating what we want to put in here. All right, we are back today. We're going to get started on this equipment replacement. We're going to recover the refrigerant from this old unit, and then break this one free and start placing the new unit. We're going to try to utilize a lot of the existing stuff if we can. Well, I don't know. Let me look at this. I don't think I'm going to use this defrost cloth. We're probably going to put in a new one because this thing's pretty beat up. Look at the inside. Yeah, it was last changed in 09. I'm not going to trust that. And You know, I was wondering if I would reuse this, but no, because I don't know what killed the compressor and I don't want to take the chance. So we're going to put in a new condensed unit, new dual pressure control, new time clock, dryer, sight glass. It's going to look something similar to this one over here. I got the same, it's basically the same condensed unit, same receiver. We're going to set all that stuff up, see what we can do. So this is my new condensed unit. It is just a 1/2 horsepower condensed unit, but we're only running 1800 BTUs of coils. So we're good on that. I think we get like 4,400 BTUs out of this at like 110 degrees ambient or something like that. So there's more than enough power in this condensed unit. But it's an indoor condensed unit. The difference between indoor and outdoor a lot of times is the receiver size. Notice that receiver is like a 2-pound receiver. We're gonna go ahead and take that receiver off and put a 6-pound receiver on this guy. It's gonna be identical to that one that I have right there. So we're gonna put the 6-pound receiver on it and then just kind of pipe everything in. This is a 230 volt, so we'll get rid of this plug and redo some stuff and it'll all work out. So I don't have this all planned out, but I'm kind of figuring it out as I go. Put a piece of strut under there to kind of elevate the unit a little bit. And then as far as this electrical cover, there were screws from each side, and it's pretty common that what we do is we take one screw out, reverse it, go that way, so that way it hooks like that, and then you only have to do one screw for one side. It makes it a little bit easier when you're servicing things. So that's one thing. So I'm just kind of taking the unit apart and it'll kind of come to me how I want to pipe this. Like I said, I don't have a grand plan as of yet, but it'll kind of figure out. I know the receiver is going to end up mounting over here, so we'll figure that out and just kind of work our way through it. So every time I try to light my torch, it's making an ugly flame and it keeps burning out. There's something wrong with it. It's because it's dirty. So we turn everything off, okay? And what I do is take a piece of sandpaper, run it flat, cleans the tip off, then I turn the oxygen on, and I'm gonna use my torch cleaner tool. That one's too big, so it's like the next one down. There we go. These things are all jacked up, but there we are. All right, so that's it. Then I turn the oxygen on and run it in and out so you don't shove crap into it. There. So now we should be able to light it. And it's a solid flame. So just a dirty tip, but you gotta make sure you clean them. All right, so put a little bit of NYLOG on the mating surface right here, and then also on the threads. I've got a Rotolog gasket in there, so we're just gonna put a tiny bit of NYLOG on the Rotolog gasket. I know it's not supposed to use your finger, but I just kind of spread it on, put a little bit on there, it doesn't take much. And then it's gonna be hard to show on camera, but just put a tiny bit right here, right on the top of the nut, and kind of move it up and down. That way it lubricates the nut. So we've got a piece right here that we just flared. It's all good, nice good flare. So I want to point out the NYLOG, okay? Right here, just a little bit, and it's right where the flare meets this top. So that way it doesn't twist when you go to tighten it. That's one of the most important places to put NYLOG. It's just lubricating the metal. Right there, boom. Spin it on, and then right here, just the tiniest bit right here. That's more than enough. And then we'll torque it on with our highly calibrated torque wrench in a minute. I've got a dryer right here. Same thing, tiniest bit, boom. Doesn't take much. Tighten it on in a second and then finish it all up. All right, we got everything piped in. Well, that's where we're gonna stop today. So we still gotta get a bunch of clamps because there's unistrut right here, unistrut right here, right there. So we're gonna come back with clamps. We'll straighten out the pipe a little bit. Tomorrow we gotta come back, we gotta do electrical, but we've got it all piped in. Clearly see the spoiling catch-all and see-all, and again, I go flare with those guys. Put an oversized receiver, got rid of the old receiver. Also got rid of the old king valve that was over here. There's no need for that because we put the receiver over here. We'll end up putting a service T on this for the high pressure control, so you'll be able to change it when you shut that valve. And then low pressure control, we'll put a T right there. So yeah, we're doing good. Like I said, we'll finish the electrical tomorrow, time clock, dual pressure control, all that good stuff. All right, we are back this morning. Got the battery chargers back and going. We're trying to do a charging party right now because everything's dead. First thing we need to do is get the dual pressure control mounted, because then I can do a pressure test. Once I get nitrogen in there doing a pressure test, we'll start doing electrical and everything else, but we want to try to be as efficient as possible. We're also going to be mounting everything with the Hydrosorb clamps. We got to figure out a bunch of different stuff, but we should have it up and running hopefully today. All right, I'm getting ready to put these guys on. Now I could weld on fittings and stuff, but you know, we're going to just do this. This will be easier. But it's important when you get an opportunity to remove the Schrader depressors. It's a potential restriction. If you get the right ones, these are the JB ones, those things pull right out. And it's this little guy right here. But at the same time, sometimes, depending on the valve that you're using, it can like deform stuff in there too. It's kind of hard to explain, but it happens, where it won't seal tight because this thing's jacked up. So anyways, I pull those out whenever possible. In this situation, we're putting these on, so that means that these valves are always going to be cracked all the time. So it's going to be really important that we make sure they're always tight. All right, we're installed. What I ended up doing, cool thing about these things, you get to do what you want, right? Because you're rewiring it. I pulled all new wires over here, okay? Oh, speaking of that, we're going to land those wires. We ran the dual pressure control. We're currently pulling a vacuum right now. It's coming down. It's going to take a while. I'm doing a one hose pull. Put a time clock right here. So what's happening is power comes from here, goes into the time clock. I already got the covers all put on. Then comes out of the time clock, goes into the dual pressure control, comes back to the time clock. Then that sends 208 single phase to the condensing unit. So the time clock is the controller. The time clock has all the power, as long as the fuses are sending power to the time clock. So yeah, we're there. We're just kind of in cleanup mode, organizing stuff. We'll get some silicone, we'll start charging. We still got a little bit more to do. We clamped everything as best as possible. Now this isn't gonna be perfect. We're not trying to reinvent the wheel here. Ran everything right here, clamped it, secured it. We'll figure out a way to secure this right here, maybe something, you know. We're working on it, but it's looking good so far. It was taking a little while, so I ended up hooking up a second hose, but we're already done. The vacuum's kind of dancing around right now, 230 microns. It's in its decay right now, so it's rising, but we're good. We're gonna go ahead and I got some refrigerant right here. We're gonna get ready, put some gas in there, and see if we can't get this guy started up, and hopefully everything's good. Now, this is an existing R22 system, and I didn't cover this, but the customer chose not to replace the evaporator coils. So we are using the existing evaporator coils with the existing R22 TXVs. We shouldn't have a problem as far as the 448A goes, because it already takes pretty much R22, well, it takes R22 TXVs for 448A. So the only place you got to be careful about, because we're switching from mineral oil to polyester oil, is with the seals. You know, depending on what type of TXVs, I don't know if they have rubber seals in them or not. Those can start leaking eventually. But I think for the most part, everything is flare joints in a lot of places, and we shouldn't really have a problem with there. But I warned the customer, you know, we may run into some issues, but they just wanted to change the condensing unit, so that's where we're at. All right, well, we just energized the circuit, but I have the unit in defrost. The light's on, so we know I have the defrost clock wired right. Well, we think. We still have to turn it on and see if anything blows up. So we're still in a vacuum because I only have gas in the high side, so I need to open up the receiver, let it run through. Went ahead and turned the defrost clock on. Here we go. Gas is coming up. Should turn on about 20 PSI. If I did it right. Somewhere in there. There we go. Just turned on. And we're gonna watch the sight glass, and then we'll go ahead and let it run for a minute and then add gas as needed. Looks like something pumped down. I don't think it has enough gas in it, to be honest with you, because I only put in about 2 pounds, so we're probably gonna have to add some more gas. looks like we're short cycling. So I've added all the gas that's in that tank. There's not really any more in there. So I brought up another cylinder because there was only a couple pounds in there. We're gonna put that on now. That was actually my bad because I had this closed right here. So as I was trying to add more gas, there still isn't a lot of gas in there because I can hear it's just vapor being fed into there, but we're still putting in what we can. And then we'll grab that other cylinder and add it. But yeah, that's much better. It's running at least. So, okay, well, we're gonna add it until we put the other gas in there. I switched over to the other cylinder. We're adding gas now. It is 448A. The sight glass is just starting to flash. So we're just kind of trying to do it slowly because we don't want to overload it. Right now the expansion valves are wide open, you know, so we don't want to kill them. Just adding a little bit at a time, letting it drop the box temperature. Suction line's cool, not cold at all. This thing's been down for like 2 weeks, so it's gonna take a while, and we gotta charge it slowly. We don't wanna overcharge it. It's not the prettiest thing in the world, but what I do on the capillary tubes and stuff is just lay some silicone there. It'll dry and it'll harden and keep them from rubbing against each other. And we can clean off the little tails later. I need to come up with a solution to mount that dryer, but I went ahead and put some silicone under it for now. We'll get something. And we're just finishing it up. It's just about to clear on the sight glass. We're almost there. So just adding a little more gas. And yeah, baby steps. So we're looking good so far. All right, so the sight glass cleared, right? And then it ran for another 20 minutes. And then all of a sudden, it pumped down. Suction pressure went down and the compressor just shut off. Now, I haven't touched those evaporators in 2 weeks. So it's possible that they're satisfied, but it's also possible that the temperature controller's set too high. So I sent a technician down there. He's got 2 thermometers. He's gonna go temp the boxes and see what happens. All right, we've seen both of them turn on and turn off, and they're at the right temperatures. Everything's good. The only thing I gotta do is when I come back another day, just come up with some sort of something to clamp down that dryer. But for now, I put some silicone under it. Should be good. We made sure that each one of these guys is still cracked open because they always need to have pressure because of the pressure controls. That's one downside to doing it this way. The plus side is that if we ever have a pressure control failure, all we have to do is backseat the valve and we can replace it. If we put it on the high side by adding a service port or something, then you can't replace it without recovering the charge. But if someone comes over here and backseats this all the way, it no longer has high pressure control. So it's kind of a catch-22, which one's more important kind of a thing. I know people are probably gonna say it's more important to sense the high pressure, but I find this to be easier that way because I don't really have problems with it because I'm the one mainly working on this stuff. So it's just usually how we roll. So everything's good. We're gonna put this eyebrow back on and we're done. These are some of my favorite types of jobs, to be able to design and fabricate the way you want things to work, installing a new condensing unit, repiping it, you know, modifying it. It's just fun. And to be honest with you, I love going into these without very much of a plan. Like I have a general idea that, hey, I'm going to use this unit and I need to put a bigger receiver, but I like to just get in there and set the unit down and kind of figure out, okay, the piping's going to go here. You know, I'm going to do this, and oh, if I move this here, it makes it better to do this. Like, I love doing that kind of stuff. And I have to be thankful for the types of customers like this. They just told me to do the job. Just, they knew that, you know, they trust me. So they were just like, just put in a condensing unit, you know, and I'm thankful for that kind of stuff. Now, I did give them the option, hey, we should, you know, do you want me to change the evaporator coils too? And they're like, yeah, let's just do the condensing unit because they needed it operational. So it's just fun. I really like this. I think there's something about the fact that I'm able to just go up onto the roof and just spend, you know, a day and just have at it, you know, and just make things work the way that I want them to work. I really dig doing that kind of work, you know. I also have a stainless steel fabrication shop that I go in and do custom work for them too when I get to build boxes. I've kind of showed it on the channel a few times. That's always fun too, to be able to go in and just, you know, figure things out. It's kind of neat. And sometimes, I mean, I don't want to do it all the time, but sometimes it's neat just to get away from the service side and just get in here and get to fabricate things, you know, and come up with design ideas, and it's always fun. So nothing too complicated about this job. You know, I confirmed the diagnoses and then just kind of went in there and put a new condensing unit in. So we had to remove everything, kind of start fresh, and then just figure out how we want everything to work and where we want the piping to go, so that we would potentially eliminate future issues with rub outs and things like that. So yeah, not really overly complex, you know. Again, I have a general understanding of the electrical setup and how this thing's wired and how I want it to work. Now, on the downside, there's no schematic really breaking down what's happening here, but it's not going to be hard to figure it out if someone came in behind me. I mean, it's pretty simple. Main power comes into the defrost clock, comes out of the clock, goes through the pressure control, comes back into the clock, then goes to the condensing unit. It's not that big of a deal. A person can probably figure it out just unplugging everything and, in half an hour or something like that, and just kind of figure out what's going on in there. But it's always fun to be able to do this kind of work. But again, we still have to use common sense and use our technical abilities to be able to anticipate potential problems that may come up if we design it or set it up a certain way. So you always got to be able to think about that kind of stuff, and experience helps with that. I really, really appreciate you guys making it to the end of the videos. And I say this all the time, but I truly mean it. You guys are amazing. Thank you so much for the support. If you guys are interested in supporting the channel financially, the easiest way to do so is actually just watch the videos from beginning to end without skipping through anything. That's the simplest way to support this channel, okay? It doesn't even cost you a single thing except for a little bit of your time. The next way, there's a couple different methods. You can donate to the channel via Patreon, which is a monthly commitment. It charges your credit card, and I believe it sends you an email before it does that. You can choose an amount. YouTube channel memberships, which is just like Patreon, just another monthly commitment kind of a thing. There's PayPal donations. HVACRvideos.com is my website. We have merchandise available. My wife and I package the merchandise and ship it out. You can see some of the shirts back here. We have hats, beanies, sweaters. The sweaters, they don't sell as much because I don't think I really advertise them as much, but they're a really heavy duty zip up hoodie, really nice quality. Says HVACR videos on the back, and has my snowflake icon on the front. I only offer them in a zip up hoodie. I know some people have asked me if I have pullovers. The thing about, I know a lot of people say, hey, you need to get this, you need to get that. The thing is the way that I do my merchandise is I pay for it up front. So I have a huge overstock of merchandise, and for me to go and order new shirt designs or redo this or redo that, I pay that money out front, and then I have to hope that it sells. So I'm very cautious about ordering new stuff, new designs and things like that. So I'm not saying that I won't do any other designs, but in the future maybe we will, but I have to do it very carefully, because sometimes if you want to do these big merch orders, it's a lot of money, like a lot of money. To place a big order and shipping and everything like that, and then you got to store it. So I probably have 1, 2, 3, 4, 5 of those totes in here, and then I have another office that I have like 15 of those totes. So I have a lot of merchandise, but by ordering it ahead of time like that, I get a bigger discount and stuff like that. But anyways, enough on that. Last way to support the channel is from TrueTechTools.com. If you're interested in purchasing any tools, check out TrueTechTools.com. I have an offer code, big picture. I get a very small commission if you guys use that offer code. And then also I have an affiliate code with them. So if you know what you're going to buy, shoot me an email, let me know. I can generate an affiliate link. You still get to use my offer code, but I get a little bit more of a commission. I'll get a commission from the offer code and a little bit of a commission from the affiliate code too. So if you're interested, you guys don't need to. I'm going to continue to make these videos. I really, really appreciate all the support that I've gotten from so many of you guys. It's very humbling. I see myself as just a normal service technician, so the words of encouragement and thank yous and all that different stuff it's such a trip. It's so humbling. That's the only word I can use to describe it, because I'm just sharing what I consider to be common sense with you guys. And I realize it's not as common for other people, but I'm not trying to flex or anything. I'm just saying that sometimes I get like an imposter syndrome thing. Like, why am I qualified to do this? I'm just a normal technician, but hey, it's just definitely a cool experience. So thanks so much for all the support. I really, really appreciate you guys. Okay. We will catch you on the next one. All right.